What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be talking about the oxidation of alcohols. So in previous videos, we talked about reduction using LiAlH4 and NABH4. Today, I want to talk about how we can oxidize things instead of reduce things, okay? So let's go ahead and jump into it. Here, I went ahead and showed us a secondary alcohol, right? This whole series has been about alcohols. Now, we can oxidize this alcohol into something that's more in an oxidized state, okay? So how we can do that is using an oxidizing agent. Oxidizing agent could be CrO3, so we could call this guy Jones, or we could have done PCC, okay? So either way, it's going to give us a product that looks like the CH3 group was just a distractor, nothing going on there. Our OH group turned into a keto group. Check that out, okay? Now, we don't need to know the mechanism, we just need to know how it works, okay? So this OH, this O had a hydrogen here, and there was a hydrogen there. Notice, we went from a state with more hydrogens to a state with less hydrogens, okay? So a way to identify if something has been oxidized is either if there are more oxygens, okay? In this case, we have the same number of oxygens, or there are less hydrogens, okay? So those are key characteristics to look for when we're trying to decide if something is oxidized or reduced, all right? So in this case, we could have done Jones or PCC. I will say Jones, this guy, is stronger than this. This is a weaker oxidizing agent. Now we'll get into that in just a moment. Let's go ahead and look at our next example. So example number 2 here. Example number 2, what do you think the major product will be? Well, we have a primary alcohol in this case, okay? And we need to know what we're reacting it with. Let's say we react it with PCC. Do you think that we would get a ketone group here? What do you guys think? So this formed a ketone group when we did Jones or PCC. That's because at this carbon, we had an R group coming off of here and an R group coming off of here. Notice, coming off of this carbon, we only have one R group, and then we have 2 hydrogens, okay? So if we use PCC, we're going to get something that looks like the following. This is known as an aldehyde. This is our aldehyde functional group. Now, notice, this is not the ketone, this is an aldehyde. The reason for that, like I was saying, is this carbon was bonded to 2 R groups, and those 2 R groups can be found here, and that's what forms the ketone group. This primary alcohol is only attached to 1 R group, so here's that 1 R group right here. That means to the right, we're not going to have a second R group just like up here. We're going to have a hydrogen because we have 2 hydrogens right there. So this is going to give us the aldehyde. Remember, this is the weaker. So what happens if we used a stronger oxidizing agent? So what if we did CrO3? Remember, this is a stronger oxidizing agent, okay? And I'll just put down here PCC and CrO3 are oxidizing agents, okay? Which means they're oxidizing something. So let's see what we get. We're going to get something that looks like this. This is known as a carboxylic acid. This is a carboxylic acid. Now, if I started with CH4, let's say I had CH4. This is the most reduced we can be. And I can slowly start to oxidize it. Let's say I was a CH3OH, and let's say I eventually became a C double bond O with an H, and maybe there is an R group over here. And then I kept going, and now I'm at the carboxylic acid. As we keep going in this direction, all the way to C double bond O, this is CO2, we are oxidizing, okay? So this is the oxidizing direction. If I went the other way, if I was going in this direction, this is reducing, Okay, but in this video, we're oxidizing. We're taking the CH3OH and we're forming an aldehyde group or a carboxylic acid. In extreme cases, we can form the CO2, but we're not seeing that in this video here, okay? So that's just to show you that these are oxidizing agents. This is the oxidation of alcohols, and we are forming ketones, aldehydes, or carboxylic acids, depending on if we're primary, secondary. Let's check out and see what happens if we were tertiary. So what would happen if what if instead of my OH being here primary, or even being secondary, what if I was tertiary and I did CrO3, or PCC? What would we get? We would expect to see no reaction. This is no reaction. That's because at this carbon right here, there's no room to put in a double bond O. We can't get rid of any hydrogens. There's no hydrogens there. We need to have available hydrogens at this carbon in order to do oxidation. So since these are R groups, just like that, 2 R groups, then we can't do any oxidation. Whether it's a weak oxidizing agent or a strong one, we're not going to see any reaction take place here, okay? So remember, this was a tertiary alcohol. So now we got to see the differences between primary, secondary, tertiary, and the different reagents and our products, all right? Thanks for tuning in, guys. I'll see you next time.